Hello everyone, I'm Chris from Next Data. In 2025, we successfully hosted the first MLC SLM challenge and got some truly impressive results. Today, I'm pleased to be joined by Dr. Mu, a member of the organizing committee for the MLC SLM challenge. Dr. Mu, thank you for joining us today. Before we start, could you introduce yourself first?
Yeah. Hello, everyone. My name is Bingshen Mu, a PhD student from Northwestern Polytechnical University. I'm one of the main organizers of the first MLC SLM challenge and workshop. My research focuses on the optimization of LLM-based ASR models in complex scenarios, such as multi-accent, multilingual, and conversational scenarios.
Thank you for your self-introduction. Today, Dr. Mu will share with us a summary paper on the first MLC SLM challenge. We'll also provide to share that this paper has been accepted by ICASSP 2026. Alright, Dr. Mu, could you walk with us through the paper and share some of its highlights?
Oh, yeah. I'm honored to present our summary report on the multilingual conversational speech large language model challenge, also known as the MLC SLM challenge. This work is a joint effort with my colleagues from NPU Nanjing University, Nanyang Technological University, Huawei, and Next Data Technology. The MLC SLM challenge focuses on real-world multilingual conversational speech processing. And in this talk, I will walk you through the datasets, task settings, baseline systems, top methods, workshop information, and the new features of the second challenge. First, let me show you the outline of today's presentation. We will cover 6 main parts, and I hope these parts will help you understand the full picture of the MLC SLM challenge. Now let's begin with the introduction. And the MLC SLM challenge has 2 main goals. First, to release a high-quality, real-world, multilingual conversational speech dataset. And second, to advance research on building effective multilingual conversational speech large language models, or speech LLMs. And the challenge was quite successful. We attracted 78 teams from 13 countries around the world. In total, we received 489 valid leaderboard results and 14 technical reports for the two tasks. And participants came from both industry and academia, and maybe 34 teams from companies and 43 teams from universities, showing strong enthusiasm from both communities. And as planned, we now move to the second part, task settings and rules. We designed 2 core tasks for the challenge. And the task 1 is multilingual conversational speech recognition. The goal is to build an LM-based automatic speech recognition model for multilingual conversational speech. And during evaluation, participants are given oracle segmentation and speaker labels. We use WER or CR for each language and MER as a final metric. And the task 2 is multilingual conversational speech diarization and recognition. This is more realistic and challenging task. The system must handle both speaker diarization and speech recognition together. No oracle information is provided during testing. We encourage both pipeline and end-to-end systems. The evaluation uses TCP-WER, TCP-CER for each language, and TCP-MER as the overall metric. And all evaluation metrics are computed using the Meet-Eval toolkit. a key requirement is that all systems must be based on speech LLMs. Participants are allowed to use public external datasets and pre-trained models, including speech foundation models and LLMs. And data augmentation is permitted on the training set, such as adding noise, reverberation, and tone modification. Strictly prohibited actions, including using evaluation data for fine-tuning or training, and any form of system fusion. All submissions must come from a single system, not fusion of multiple systems. And next, we move to the second part, release dataset and baselines. We released a large-scale multilingual conversational dataset for the challenge. The total duration is 1,604 hours, and including training, development, and evaluation dataset. The dataset covers 11 languages, and the English subset includes 5 accents. Each recording is a two-speaker multi-turn conversation, lasting about 20 minutes on a random topic, making it highly realistic. The evaluation dataset and annotations are open sourced on the Next Data website and Hugging Face. The task 1 baseline follows a standard speech LLM structure, a whisper large encoder, a projector layer, and a convolution and with convolution and linear layers, and an LLM decoder using Kun or Llama LLMs. We use a two-stage training strategy. First, we train only the projector, and then we jointly train the projector and LLM using LoRa for better efficiency and performance. The task 2 baseline is a cascade pipeline. We use the 3D speaker toolkit for speaker diarization and the pre-trained speech LLM from task 1 for ASR. The whole process has three stages. We first fine-tune the Pioneer segmentation model for overlap detection, and then run Diarization on development and evaluation dataset. And finally, split the audio and feed the audio segments into the ASR model to get the transcriptions. Let's look at the baseline results. For task 1, Whisper performs better than our speech LLM baselines, partly because it uses language identification, while our baselines do not. Also, our speech LLMs show obvious hallucination during inference. For task 2, the Diarization module without overlap detection works better because actual overlap in our data is very short, and too many small segments lead to higher TCP/MER. We have released all the baseline code on GitHub for reproduction. Now we come to the fourth and the most important part, methods of task 1 and task 2. For task 1, we collected results and reports from the top 9 teams. They achieved very low MER by using advanced model architecture, careful training strategies, effective multilingual adaptation, strong data augmentation, and large-scale external data. This method shows us a clear path to build a better multilingual conversational ASR system based on speech LLMs. Almost all top teams used the same mainstream structure, speech encoder plus projector plus LLM decoder. Popular encoders including Whisper models, mHubert, and MMS. Projectors are usually simple and effective, like two-layer linear or convolution linear structures. They also used latest strong LLMs such as Queen 3 and Gemma, Llama series, and others. Top team used flexible training strategies, including one-stage, two-stage, and three-stage, even multi-stage training. A very common pattern is to first train the projector layer, and then jointly train the projector and the LLM, often with LoRa to save computation and avoid overfitting. To handle many language well, top teams used several effective multilingual adaptation methods. These include language-specific prompts, special language tokens, separate LoRa for each language, and MOE LoRa with weighted fusion. These designs greatly improve the model ability to handle different languages. And another important technique is using conversation context. Top teams feed the model previous or even future utterances to help it understand the dialogue better. And they also used constructive learning to strengthen semantic coherence in the conversation, which noticeably improved ASR accuracy. For task 2, we summarized the top 6 teams that submitted technical reports. Most of them used Cascade pipeline with strong VAD and speaker embedding models, and achieved very competitive TCP MER scores. Their works showed that better practice for joint diarization and recognition in multilingual dialogue. Systems in task 2 mainly fall into 3 types: cascade and semi combination and end-to-end. Cascade systems do diarization first and then ASR. Semi-combination systems use diarization-aware multi-speaker ASR model. And end-to-end systems predict speech identity and text at the same time using sliding window and context prompts. During inference, top teams used several useful tricks. They applied model averaging for more stable results, tuned decoding parameters like beam size and repetition penalty, and post-processed diarization results by merging short segments from the same speaker to reduce errors. And teams also made full use of external data and augmentation. They use large public ASR datasets like Common Voice and GigaSpeech, and diarization datasets like ARMY and Voxelable 2. Common augmentation methods including speed and volume perturbation, noise injection, reverberation, and spec augmentation. They also filtered low-quality data to ensure training stability. That's all my presentation. Thank you for listening.
Alright, thank you again, Dr. Mu, for your wonderful showing. And for everyone watching, the situation for the second MLC SLM challenge is open now. Please check the video description for the details. Thank you again.
Thank you.